In this session, I will discuss working with the list data type. It's a data type that contains multiple values. Therefore, we can put a lot of data in a list. The purpose is to manage the sequential data in a structure so we can keep track of the data. If you're interested in more content, feel free to read the transcript on GitHub or download the source code. Also, like this video and subscribe to my channel. Plus, follow me on Twitter, connect with me on LinkedIn and Facebook. In the IDE, to create a list, we start with an opening and closing bracket. Each value, such as 5, 8, 2, 1, 7, 8, in the list is called an item or element that is separated by a comma. Since there are multiple items, normally we assign the values to a name that ends with an S, like numbers. We can create a collection of items that include numbers, true-false values that are Boolean, and letters, like capital A, lowercase a, capital X, lowercase b. Also, it can include names like Jane, John, and James. If the values are related, it can also be a combination of numbers and letters. Python allows us to create a list within a list like Booleans, values that contain square brackets within the square brackets that are separated by a comma. First list item can be a 0, false. Second list can be 1, comma, error. Now, 1, comma, that'll be true, and next would be -1, and that can be error. To print, we pass in the name of the list, such as numbers. Print, how about letters, and also print Booleans. When I run, we see each value in the console for numbers, letters, and the Booleans. Now, we have a function that count the number of items in a list, or how many times an item appears in a list. And that is the len function, which means length. So if we want to see how many items are in a list, we place len before each list name. Len numbers, len letters, and len Booleans. Run, and the console returns 6, 7, and 3. Notice how the list within a list shows 3 and not 6. That's because each list is considered one value. However, the len function is different from the count method. The count method returns how many times a particular item is in a list. For example, if I erase these print statements and type print numbers, then dot count, and pass in the number 5, then run, we see 1 in the console. Therefore, the 1 in the console shows how many times 5 appears in the list. Now, if I change 5 to 8, we see 8 shows up twice. So now run, the console shows 2. To access each item in the list, we print numbers, then the square brackets, then pass in the location. Each item in the list has an index position that starts with 0. Therefore, the first item, which is 5, represents index 0. Inside the square brackets, when I write 0 and run, the console returns 5 because it is the first index, the first item, which is index 0. Now, I'm going to pass in another value, but when it comes to 0, we know it's the first index. We can also count backwards, count the last index, and count backwards, we can use a negative number. However, the indexes start at 1 when using an index number. Let's use a different list by changing numbers to letters. Then pass in -1. Then run, and the console shows James because it is the last item in the letters list. Accessing a particular item is different for a list within a list. If I replace letters with booleans, bingo, then run, we see one error in the console because it is also the last item. When I replace -1 with 0, this time when I run, watch what we see. 0, false, because it's the first item for index 0. To access an individual item in a list within the list, we need 2 sets of square brackets for the print statement. And to access that list, let me show you by adding a comment. And we already know that 0 and false is index 0. So for 0, I'm going to write 0, 0. For false, I'm going to write 0, 1. Index position 1 is 1 and true. Therefore, if I write 1, 0, that's for 1. And if I write 1, 1, that's for true. Moving on to the next item, it's the same. -1 is 2, 0. And error is 2, 1. So if I want to print true, I would add 1, 1 in the square brackets. Run, and the console shows true, which is 1, 1. Let's look at a couple of errors for the numbers list. We see there are 6 items. 1, 2, 3, 4, 5, 6. So if I print numbers, then pass in 6 and run, the console shows index error that says list index out of range. It's out of range because the index starts at 0 and the last index stops at 5. Another error for this here is the type error. But let me explain the index error right quick. Python searches this list and realizes there is no index 6. That's why it throws an index error, because it's out of range for 6. But we know that if I pass in 5, it'll be all good for the last number 8. Now, Python only allows integer values for the index position and not float values. Therefore, if I change 5 to 1.0 and run, the console shows type error and does not print the second value. The error says list indices must be integers or slices. Next, I will show you how to slice a list, also demo how to add items, remove items, and sort items in a list. Thanks for watching, and I'll see you in the next session. In this video, I will continue from the last session, which introduced a Python list. The list value is a mutable data type. That means a value can be added, removed, or changed. Recall from the strings video, a string value is immutable, meaning it cannot be changed. The focus of this video will be slicing a list and modifying a list. If you're interested in more content, feel free to read the transcript on GitHub or download the source code. Also, like this video and subscribe to my channel. Plus, follow me on Twitter, connect with me on LinkedIn and Facebook. In the IDE, let's start by slicing a list, which is similar to the range function. We slice by defining two integers that will return one value and form a new list. Return more than one value and form a new list. Therefore, I will type 1:5. Index 1 will grab number 8, but index 5 will stop and not print the last item, number 8. I'm going to add a print statement before and after the slice. Print numbers. Numbers. And I'm going to do the same below it. And when I run, we only see numbers 8, 2, 1, and 7. Python prints a slice of the numbers list. The second integer always go up to an index position and stop, but will not include that item. As a shortcut, we can remove one of these indexes or both of these indexes without the second integer. Index 5, the slice evaluates to the end of the list. Run, and this time we see 8. All of the numbers are 8, 2, 1, and 7. The starting index is similar. Without the starting index, then the slice starts at the beginning of the list. If I add 3 for the second integer, which is number 1, and remove the first integer, then Python will automatically start our slice at index 0. Run, and this time we see 5, 8, and 2. Now, let's modify the list by changing, adding, removing, and sorting the items. To change a value, we write the list name like letters, square brackets, then the index number 6. 6 is the last item value for James. Assign a new value like Janice. Print letters 2 times. Now, the updated list shows Janice. There is more than one way to add an item to a list. We can insert, append, and extend. To insert, we write numbers dot insert. Insert takes 2 parameters. The first parameter is the index where we want to add the item. How about position 1? Now, the second parameter is the value we want to add, and that is 34. I'm going to print numbers 2 times. Run, and the console shows 34 was inserted at position 1. The other items get pushed to the right of 34. If we want to add an item to the end of our list, we can use the append method. Write letters. Now, when I write letters, I'm going to also print it before and after the append method. Now, the letter we want to append, or the name I'm going to append, is Jackie. Run, and the console shows Jackie. The append and extend methods are similar and can be confusing. Both methods add to the end of a list. However, it's best to use append when adding one item and extend when adding more than one item. Let me show you the difference. We see how append display Jackie at the end with one item. Watch how extend operates. Now I'm going to run, and we see how the console shows each letter as one item. Watch what happens when adding more than one item. Let's say we have another list called letters underscore 2. And I'm going to pass in some values like Jackie and Joe. To extend, we write the letters or the list name, letters 2. Then run. And we see Jackie and Joe are added to the end of the list. That's good. However, when it comes to append, when I run, Jackie and Joe are still added to the end of the list, but look how it's added to the end of the list. It's added to the end of the list by looking like a list within a list, just like the Boolean list of values. We prefer not to have a list within a list, but have each individual name. Let me show you why. Add one more print statement to this at line 10. And I'm going to return letters. And I'm going to pass in 7. And then run. And the console shows the complete list and not just Jackie, which is Jackie could probably be number 7, but it shows the complete list. That's why it's best to use append for adding one item and extend when adding more than one item. I'm going to erase all these print statements, or just this print statement. And let me show you about remove. Letters dot remove, then pass in a value like X. Run, and the console does not show the letter X. It was removed from the list. If you know the position of an item, then you can use the DEL statement, then write the name of the list, which is letters, open and square brackets, and pass in 0 and run. And we see the capital letter A was removed from the list. Another method is the pop method. By default, it removes the last item from a list. We write letters dot pop, then run. And we see James was removed from this new formed list. Pop is unique because it allows us to remove an item but still work with that item. Assign letters dot pop to a value like popped underscore letter. So now when I run, I'm going to pass in popped letter by adding another print statement, then run. And we see James was removed from the list, but also displayed at the end because we can still play with the list. For sorting an item, we write numbers dot sort. I'm going to also print numbers before and after the sort method. Now we run, and we see the items are in ascending order: 1, 2, 5, 7, 8, 8. If we want the items in descending order, then we pass in reverse equal true. So now when I run, we see it starts from the back by 887521. we can reverse the list to show the last item first and the first item last by writing numbers dot reverse. This time when I run, we see it shows 8, which was the last item, and 5, which was the first item last. Now, when it comes to sorting alphabets, this is interesting because if I write letters dot sort, there it is. Watch what happens when we print. You see, if you notice, the lowercase letters A and B are at the end of the list. They are not sorted in alphabetical order. The sort method using ASCII alphabetical, the sort method uses in ASCII-betical order and not alphabetical order. ASCII-betical order means all uppercase letters comes before the lowercase letters. To sort in alphabetical order, we can pass in key equal to str dot lower, then run. When I remove these parentheses. There it is. Now we see the list is in alphabetical order. Thanks for watching, and I will see you in the next session. In this session, we're going to look at tuples. A tuple data type is similar to a list data type. However, there are two differences between a tuple and a list. First difference is the tuple data type requires parentheses, while a list requires square brackets. Second, a tuple is immutable and a list is mutable. Therefore, we cannot change, add, or remove values from the tuple data type. If you're interested in more content, feel free to read the transcript on GitHub or download the source code. Also, like this video and subscribe to my channel. Plus, follow me on Twitter, connect with me on LinkedIn and Facebook. In the IDE, let me show you the difference between a tuple and a list. Copy the list data numbers, and I'm going to paste them. And I'm going to paste one more time for the tuple data type and change numbers to nums. Next, change the brackets, square brackets, to parentheses, opening and closing parentheses. That's it. We can print the type by writing print, TYPE, opening and closing parentheses, and then pass in numbers. I'm going to copy and paste and change numbers to nums. Now when I run, the console shows list and the tuple. When it comes to methods, the tuple data type only has two methods. I'm going to print nums dot, and we see count and index. However, the list data type has many methods that includes count and index. There are more methods for the list data type because they involve mutating, better known as changing a value. I'm going to print nums dot count. Count lets us know how many times a value shows up in the tuple. Pass in 8, then run. As expected, the console returns 2 because there are 2 number 8s in the tuple. How about if I change 8 to a number like 9, then run? The console returns 0 because there are no number 9s in the tuple. How about number 5? We see 1 because there's only one 5 in the tuple. The index method lets us know the position of a value, so change count to index, then pass in number 8. Since there are 2 number 8s, Python will only return the first 8 in position 1. Run, and we see 1 in the console. The tuple data type only has 2 methods because they are immutable, cannot be modified. If we try to modify a tuple, then Python will return a type error. For example, if I write nums, open and closing parentheses, 0 equals 3, this is a command to try and change the first number, 5, to a 3. We already see a brown background. Hover it, and it says tuples don't support item assignment. I'm going to write for the list. It's no problem. If we assign a value to the first item for a list data type by writing numbers, open and closing parentheses, square brackets, equals 3. Also print numbers. And I'm going to also print nums. I'm going to run, and the console shows type error. Tuple object does not support item assignment, but shows an updated list that includes 3 as the first number. That's because there's no problem with assigning a different value to a list data type. However, most engineers use a list data type because there are more use cases to change, add, or remove a value. However, the tuple data type maintains protection when we do not want a value or a set of values to change. For example, if we had a program that involved coordinates, coordinates are a set of numbers that identifies a point on a line. We should not change a coordinate because it locates a point. I'll write coordinates as the name, and I'm going to make the values be 2, 3, also 3, 4, and 1, 5. 2 and 3 is one coordinate. 3, 4, and 1, 5 are the other coordinates. Print the second coordinate, which is 3, 4, by writing print coordinates. And I'm going to pass in 1, which is the second set of items. The index position always start at 0. Run, and the console returns 3, 4. This is a use case for a tuple. Thanks for watching, and I will see you in the next session. In this session, let's look at sets in Python. A set has values that are not in order and does not return duplicates. It looks similar to a list data type and a tuple data type. Recall from the previous sessions, a list is created using square brackets, while a tuple is created using parentheses. There are 3 ways to create a set. In the IDE, the first way is by using the set function. Women equals set. Then we add parentheses. Within the parentheses, we add square brackets. And the second way is using the set constructor. Men equals set, followed by parentheses. This time, we add more parentheses inside the parentheses. The values for women will be Janet, Jane, Jazz. And we're going to add Jane one more time. The values for men will be Joe, John followed by James 2 times. So we have duplicate values for men and women. Print the women values and also print the men values. When I run, notice that the values are not in order how I added them to the set and does not contain duplicate values. Women does not contain duplicate value Jane, and men does not contain duplicate value James in the console. The console starts with Janet for women and James for men. If I keep running, the order will change each time. This time it shows Janet and Joe, Jane and Joe, Jazz and James. The third way of creating a set is by using a literal. Do you see how the console shows the values inside curly brackets? We create set literals using curly brackets. The brown background for women and men says function called can be replaced with set literal. Let's write numbers equal curly brackets. Within the curly brackets, write values 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 times. Then write 10. So the duplicate values are 9 and 1. Now let's print the numbers. When I run, the console shows an error because I did not add the S for numbers. Now we see values 1 through 10 in the console without a duplicate number that was returned for numbers. Also, a set does not support indexing. If I write square brackets, then add 1 for the index number, then run, we see type error with a note that says set object is not subscriptable. In previous Python versions, this type of error had a note that said set object does not support indexing. The error shows up because we are not able to access an item since there is no sequence order. For the set data type, we can check for a value or collection of values using built-in functions. Let's start by creating some new set data types like even numbers, odd numbers, and prime numbers. For evens, they will equal curly brackets 2, 4, 6, 8. Let's go ahead and add 0 also. And for odds, they will equal curly brackets but start with 1, 3, 5, 7, and 9. Prime numbers, they will equal 2, 3, 5. I almost forgot the prime numbers. 2, 3, 5, 7, and 11. Now, a prime number is a whole number that only has 2 factors. The 2 factors are 1 and itself. Also, they can only be divided by 1 and itself. 1 is not a prime number because it only has 1 divisor. The first built-in function we are going to look at is union. A union combines 2 or more sets, then return a new set. Let's write evens dot union, then pass in odds. This statement will unite the even numbers and odd numbers. Print, then run, and the console shows numbers 0 through 9. If we do not want to add the word union, then we can write a vertical line symbol that represents union. Odds, vertical line symbol, evens. Print, then run. We see 0 through 9 for both statements. The intersection function is another built-in function. It helps to return a new set when two or more sets have a value in common. Let's look at the even numbers and the odd numbers. The even numbers are 0, 2, 4, 6, and 8. The odd numbers are 1, 3, 5, 7, and 9. Therefore, they do not have a value that's common. So if I write evens, dot, intersection, then pass in odds, print, we're going to see what the console returns. As expected, an empty set value. Now, as expected, it's empty because there are no common values, but the prime numbers have common values with even numbers and odd numbers. 2 is the only even number that's also a prime number. 3, 5, and 7 are the only odd numbers that are also prime numbers. To see even numbers that are prime numbers, let's write evens dot intersection, then pass in primes. Now, to see the odd numbers that are prime numbers, we can use an ampersand symbol, which represents the intersection function. Odds and primes. I'm going to print the sets for both, and we're going to see what the console returns. Run, and the console shows 2 for the even number and 3, 5, 7 for the odd numbers. There are more built-in functions that we can look at, but let's look at one more function. How about the difference function? It returns a new set after checking the difference between 2 or more sets. For example, the prime numbers are 2, 3, 5, 7, and 11. Now look at the odd numbers, 1, 3, 5, 7, and 9. 2 and 11 are numbers that are not in the odd number set. Therefore, the process will look at the prime numbers, then check to see which numbers are not in the odd number set. Let's write primes dot difference, then pass in odds. Print and run, and the console shows 2 and 11 as expected. Now, let's switch it around and look at the odd numbers 1, 3, 5, 7, and 9. What's the difference between odd and prime? 1 is not a prime number and 9 is not a prime number. Let's print the difference by writing odds minus prime. The minus symbol is a shortcut for writing difference. Print and run. The console shows 1 and 9 as expected. That's it for Python sets. Thanks for watching, and I will see you in the next session. In this session, we are going to look at a Python dictionary. The purpose of a Python dictionary is to store information in key value pairs. It's a special data type structure like a list, tuple, and set. We can access information from a dictionary using the key. In the IDE, the first step is to provide a name like tutorial equal curly brackets. The next step is to write our key value pair like name. Name is the key, and make sure to include a colon after the key. The value is Python programming. Always add a comma to separate the key value pairs. We can use almost any type of data for the value. Reserved words are not good values. This time, I will use double quotes for sessions as the key because it does not matter if we use single or double quotes. There will be 40 sessions. Let's use a Boolean value for the course is underscore valuable. True is the Boolean data type. Level is a good way for us to add a list data type. And the values for the list will be beginner, advanced. Dictionaries allow multiple items with the same key, but the last value will override the previous value. So if I write level again, then provide empty quotes, we see a brown background with the note that says dictionary contains duplicate keys, level. So far, I have used strings as the keys, but a key can be any kind of immutable data type like strings, integers, floats, or booleans. It can also be a tuple if the tuple contains only strings and the numbers. We cannot use a list because it is a mutable data type, meaning it can be modified. Most of the times, the key will be a string or integer. So let's use number 1 as the key and a duplicate value like true. True is the same value that's in is valuable key. At this point, we can print the tutorial, run, and the console returns all of the keys and values. Let's get one of these values by adding square brackets after tutorial, then specify the name key. Run. We see console. We see the console shows Python programming. If we wanted to see the number of sessions, then change name to sessions, then run. Now the console returns 40. Python returns a key error when using a key that is not available. For example, if I write is valuable for sessions, but remove the hyphen or remove the underscore, then run, the console returns key error is valuable. In our program, we do not want an exception, so a better way to access an item is to use the get method. The get method does not return a key error, but it returns none. So to get this, I will change the square brackets with .get. Within the get method, we pass in a key that is not valid. So this time when I run, we see none. The get method also allows us to provide a default value if we do not want to return none. To return a default value, after the key, I will write key not available. There it is. Run, and this time the console shows key not available. If we use a key that is available, such as writing the underscore and then run, we see true. We see true because the value is true. Although we added a default value, the console returns true because the key is valuable was found. I'm going to remove the default value and change is valuable to level, which is another valid key. Then run. The console shows beginner advanced as a list data type. To see the list data type, we can write type before tutorial, then run. And as expected, the console gave us list. Now, if we want to see another value like number 1, bool, let's change the level key to 1 and run. As expected, the console shows bool for Boolean. Python allows us to update an item, add an item, and remove an item from our dictionary. To update one value, we write the dictionary tutorial. Square brackets, add the key, which is 1, inside the square brackets. And the value is yes. This time when I run, the console shows str for string as the data type. I'm going to print the complete tutorial, and we're going to see the number 1 key is updated to show yes. Now, we can also update multiple items at the same time with one statement. And to do that, all we do is write the dictionary tutorial dot update, and within the parentheses, add curly brackets, then pass in the new dictionary values such as 1, yes. Add a comma, and I'm going to also include another dictionary such as trainer. And the trainer has a value of Rex. Now when I run, we see the new values. Number 1 for yes, trainer is Rex. Last but not least is removing an item from the dictionary. There's more than one way, but let's use the pop method. We write tutorial dot pop, then pass in a value like sessions. Also print tutorial before removing sessions. And I'm going to run, and the console shows how a value of 40 sessions was printed, then removed after Python programming. That's it for dictionaries in Python. Thanks for watching, and I will see you in the next session.